Hello students, so today we are doing 5.2 and that would be inelastic collisions. Okay, and that was supposed to be a C. Inelastic collisions. Okay, so last time I taught you elastic collisions. Let's just go back and talk about what that was. So an elastic collision meant that you had two things going at each other. Okay, they collided, okay, and then they bounced off of each other. Maybe they bounced off of each other in different directions. You know, maybe they went in the same direction, but one was slower than the other. But they did not stick together. Today, what we're going to be talking about is inelastic, okay, inelastic. So if elastic meant that they bounce off of each other, inelastic means the opposite. It means that they stick together, right? So let's do an example, something like that. Okay, so this is going to be an inelastic. Now this means that two things are going to, maybe they travel at each other, maybe one's at rest, you know, just two things are going to collide. And when they collide, they both then go in the same direction with the same velocity. Yeah? You don't know that the velocity, that's probably what we're going to be calculating or something today. But we call these inelastic ones, what we call them are sticky collisions. Okay? So we have the bouncy collisions, and the sticky collisions. Okay? Now let's refer back to our formula that we used on the bouncy ones. That formula was mv plus mv equals mv plus mv. Yeah? And then all the subscripts was, this was the first mass, this was the second mass, the first mass, the second mass. This was the initial velocities of them. Yeah? And this was the initial velocity of the first mass, the initial velocity of the second mass. This is the finals. The final velocity of the first mass and the final velocity of the second mass. And that was the formula we used for all bouncy stuff, right? Now, this whole thing on the left represented before the collision, and this whole thing on the right represented after the collision, right? Now, we're going to keep that same idea. Okay, we got before and after. Now, but with the sticky collision, here's how it's going to work. Okay, so I'm going to write I'm going to go down a little bit more here. I'm going to write the bouncy equation. It was mv plus mv equals mv plus mv, right? Now, just like we spoke about, this is before, this is after, right? This is after the collision. That's why these are finals, and these are initials. And that's the first one, that's the second one, that's the first one, and that's the second one. Now, on an inelastic, this whole side's going to stay the same, okay? Because they both have, you know, their own separate velocities. But on this side, the velocities should be the same, right? So after the collision. So this is after. This is what's going to change. Before the collision is going to be the same. After the collision is going to be a little different because they both have the same velocity. So we would add the masses together because, look, they're traveling together and they have the same velocity. So we'll just call it VF instead of saying VF1 and VF2. So, and like I said before, the left-hand side will stay the same. Okay, there we go. So this is the formula for inelastic collisions. Okay, and there's going to be another formula. Let's do an example here real quick. So here's the example with this one, okay? Let's say we have two balls, and let's say this one's at rest, actually. Let's say this one's not moving, okay? And this one is moving towards it, you know, with a velocity of like 5 meters per second. Now we're going to have an inelastic collision. So they're going to collide and they're going to travel together with the same velocity. Okay? And so what I want to do is solve for that velocity. In order to do that, I need to know what the masses were. Let's say this one's 3 kilograms and let's say this one is 2 kilograms. Yeah? So this one is at rest. Its velocity is 0 meters per second. It has a mass of 2 kilograms. While this one is moving to the right with a mass of 3 kilograms at 5 meters per second. They're going to collide and they're going to travel, you know, to the right. and I want to calculate what that velocity is. Okay, so let's do that. Okay, so since it's an inelastic collision, I know I'm going to be using this formula. mv plus mv equals, and they travel together, so it'll look like this. And all our subscripts here, which are important. Okay, so this is before the collision, all of this is for before, and all of that is for after. Okay, so let's start filling out. Mass 1, we'll call this mass 1, we'll call this mass 2, okay? So mass 1 had a mass of 3 kilograms. So we're going to say 3 times the velocity. It was going at 5 meters per second, plus mass 2 had a mass of 2 kilograms, and it had a velocity of 0. Okay, that's for before the collision. Yeah, that's all that stuff before the collision. Then they collide and stick together. So now it's going to be 3 plus 2, because they stuck together, and they should have the same velocity after they stick together, right? So we just need to solve for v. At that point, you could use your calculator, or you can work it out by hand. This whole side is 15 plus 0, which is 15, equals 5v, divided by 5, and I get my answer of velocity is equal to 15 divided by 5 is 3 meters per second. So after the collision, they would travel to the right at 3 meters per second. Yeah, that's how fast they would travel together to the right. Okay, that's one form of inelastic. So now we've spoken about elastic, which is bouncy, inelastic, which is sticky, and then we have one more inelastic collision, okay, which it's not really a collision, it's more of an explosion. Okay, and so what we're going to be talking about here is, let's say something's stuck together, and I don't know, let's say you got a spring and it's holding like 2 balls together like that, yeah? And then when you let go of the spring, both the balls are going to fly out in their own direction. Yeah, this is kind of like an explosion, okay? And so let's say they both, or let's say this one has a mass of 3 kilograms, the one on the left, and this one on the right has a mass of 4 kilograms. Okay, and after they're let go, let's say this one goes to the right with a velocity of, I don't know, 5 meters per second. 3, 4, 5. And then you need to calculate the velocity this one would fly out. Okay, well, we know those two formulas I've already shown you. I showed you the bouncy collision formula, which this is not a bouncy collision, right, with the explosion. The sticky collision, but this is not sticky afterwards. It's really sticky beforehand because they're stuck together at the start. So what you're going to do is you're going to take that inelastic formula we just used, this one right here, and it basically just flips around. Because at the beginning, the masses are stuck together, right? And at the end, they unstick. Okay, that's why I still call it kind of an inelastic collision, but it's like an explosion. So this is before the collision, or the explosion in this case, and this is after. Okay, so let's give it all the subscripts. This is mass 1, mass 2. This is the initial velocity that they both have because they're stuck together at the start. This is mass 1, mass 2. And this is the final velocities of each one of them, of mass 1 and mass 2. Okay, let's do this problem now then. Okay, so the masses were 3 plus 4, and the initial velocity. Well, initially it wasn't moving, it was stuck together, so our initial velocity was 0. And this is going to be the case for a lot of these explosion type ones. The examples that a lot of people like to use is like maybe like a gun. You're holding a gun and the bullet's inside of it. So you have two things that aren't moving. The gun is not moving, the bullet is not moving. Then when you fire the gun, the bullet shoots out one side, right? And the gun has something called recoil, which shoots in the other opposite direction. And that's basically an inelastic collision. So this is the same thing here. So this is before the collision, and then after the collision, we got mass 1 is 3 kilograms. The velocity after, well, we don't know what that was, so we will put a v there, plus mass 2, which is 4, and vf2, which is the final velocity of the second one, which we said was 5, right? And remember, this is a tricky thing. You know, I even kind of want to flip this. I'm gonna switch this. I'm gonna say we want to find this instead. Okay, and you'll see why right now. and I'm going to say this one was 5 meters per second. So that's going to change this formula around, right? You'll see why I'm changing it right now. Okay, so the before the collision is still the same. After the collision, okay, the mass 1 was 3, and the velocity. Now, most people here are going to put 5, right? Now, but it's moving to the left. So remember, velocity has direction. So it's not going to be 5, it's going to be -5. Okay? That's why I wanted to flip it, because if I would have done this one, I would have put 5, and then you guys would have never seen an example that had a negative on it. So if it moves to the left, it's -5 meters per second. But they're not going to tell you that. That's something that you need to know. If it's moving to the left, it's negative. Okay, plus mass 2 was 4 kilograms. And the final velocity here would be just v. Okay, so let's work this all out. This is 7 times 0, which is just 0, right? So we got 0 equals this stuff. So let's work it out. That would make 15 plus 4v. And remember, you can plug into your calculator at this point if you want to. We subtract the 15 over. Or, I'm sorry, that was -15, because 3 times -5 is -15. So we add the 15 over, which makes it plus 15, equals 4v. So v is equal to 15 over 4 meters per second. And that's, if you wanted to write that as a decimal, you can, but you can leave it as a fraction. And here we go. There's our answer. Our velocity is 15 over 4 meters per second. So notice, we now have 3 formulas. We have the explosion formula, where they're stuck together at the beginning. You have the bouncy formula, the sticky formula, where they're separated at the start, but then stick together at the end. And then you have the elastic formula, which is they bounce off of each other, and they have their own momentum at the beginning and afterwards. Okay, so today on the worksheet you should mostly just be seeing the sticky stuff and the explosion stuff, and then I'll combine them all together for you guys for the next worksheet. Okay, see y'all later. Have a great day.